Well, hello, and welcome to Doc Onco's Physics. Keith Onco here. Today what we're going to be doing is taking a look at kinematics in one dimension. Now, kinematics is kind of a big word, one that you don't use every day in everyday life, and all kinematics means is motion, right? We want to look at the analytics of motion in one dimension. This is going to be a multi-part lesson. Today what we want to look at is we want to look at displacement, velocity, acceleration, a little bit on graphing. But we want to get those concepts down. And then what we're going to do is in the next lesson, we're going to take all those things and put them all together and come up with a set of equations that we can use to analyze kinematics or motion in one dimension, either the x dimension or the y dimension, right? And then later on what we'll do is we'll really put it all together and we'll analyze kinematics in two dimensions, both the x and the y dimension. But before we even attempt anything like that, we need to understand some of the terminology, the definitions that have to do with kinematics. And one of those definitions is the concept of displacement. Okay, most of us have been to Disney World before. Go down to Florida and we enter through the gate, and we may walk all over the place. And over on the right hand side of the screen here, what I've done is I've kind of depicted a potential path that we might take in getting from one place to another place. And that one place might be, we might start out at point A and we might get to point B. And there's a difference between this term that we call displacement and distance, right? The total distance that I might walk in going from, say, point A over to point B is I may choose the path that you can see here with all the orange lines, right? It may not be a straight path. I may be wandering around, going into some stores, getting on a ride, doing a whole lot of things, but eventually I get from point A to point B. The distance that I walked is this path that follows the orange arrows, right? The one that I just drew, right? It goes from point A, say up to point C here, over to point D, before it actually gets to point B, right? That's the total distance that I may have walked. And that distance, let's say I'm just going to make up numbers here, could be 2 miles from point A to point B. But you can also see down here an arrow that goes, a blue arrow that goes directly from point A to point B. This would be what we call the displacement from point A to point B. And the definition of displacement I give up in the upper left-hand corner here. And displacement is the change in position of some object, and that object could be a person or a car or whatever it might be, bicycle. The change in position of some object, and it's a straight line measurement from one point to the other point that also includes direction. And that's one of the key things when we talk about displacement, is that direction is critical, right? If I told you to get up out of your seat and walk for 3 meters, now you might get up out of your seat and you might walk for 3 meters, but one of the key things that's missing there is you might ask, well, where do you want me to walk? Do you want me to walk north, south, east, west, at some angle, right? If I was to give directions to someone to get from my house to their house, or their house to my house, right? I can't just tell them, well, go 5 miles, because that's not going to help them, right? I need to tell them to go 5 miles in specific directions. Like go a half a mile to the east, then 1 mile to the north, and then another 1.5 miles to the east, and so on and so forth. I need to give the magnitude, the number that's included in the distance or the direction, distance, right? But I also need to give the directions, right? It's got to be distance and direction. And when we combine those two things, we have displacement. Okay, now the definition of displacement in words is given up here. Right, so we'll circle this. Right, so this is the displacement in words, and that's nice. Again, the change in position of some object b minus a. And it's a straight line measurement from one point to the other that includes direction. Okay. Well, what is displacement then? Displacement is the change in some position. Okay. Well, if you remember from math class, the change in position is always going to be the final position, all right, we'll call it x final, minus x initial. Okay, and I shouldn't have used a p at the top here, but I did. The variable that we generally use to designate the position of an object is x, all right, and so I shouldn't have used p up here. It should really be delta x, right, the change in the position. So let's say we have a graph down here, okay, and it's best to use a graph. And I say that displacement is going to be equal to the change in position, right? So it's going to be change in position, which is x final minus x initial. And let's just look at something on the x-axis, if you would. I'm going to switch to purple here. You can see that a little bit easier. Let's say we start out at 0 here. Okay? So this would be x initial. And let's say we end up at position 10, and this would be x final. If I want to know my displacement, right, my displacement d is simply going to be x final minus x initial. Well, x final is 10, positive 10, minus x initial, which was 0, and so my displacement is a positive 10. Now, when we have a positive, we don't generally, write the positive sign down there, but it's important to understand that the displacement was in the positive 10 direction. I started out at 0, and I moved in the positive x direction 10 units. And we didn't say what the units were. They could be centimeters or meters or miles, or it doesn't really make any difference. Right? But we moved in the positive x direction. Well, let's say that instead of that, we're up on the top of a cliff, right? And I'm going to use the same graph so I can use it over again. I'm going to switch to red here. And let's say that we are 10 meters high. So this would be my initial position. And remember that displacement works in either the x or the y direction. Right? So I started at 10 meters high, and I jump down to a position where it's 0 meters in height. So this is going to be x final now. Okay, so x initial is at 10 meters, x final is at 0 meters. So what's my displacement going to be? Well, I'm going to put a little d here with a subscript of y, just denoting that this is the displacement in the y direction. Remember, the displacement is the final position minus the initial position. Well, the final position this time is at x equals 0. So it's going to be 0 minus my initial position was up here at 10. All right, and so my displacement happens to be minus 10, and we'll say that minus 10 meters. Okay, what's the implication of that? It means that I went in the negative y direction a total of negative 10 meters in this case. So I went from this point down to this point. It helps me to understand the direction that I went in, this negative sign here. Without it, I would not know what direction I went in. Right? So the direction, when we talk about displacement, is critical, and it will be critical anytime we do problems. Okay, so this is displacement. Let's do one more problem here. It has to do with displacement. And let's say that I'm going to go back to the x dimension here. Let's say I start out at 5. So this is my initial position, and I end up at minus 10. All right, so this is going to be x final. Okay, so what's my displacement going to be? Well, it's going to be in the x direction, so I put a d with a little x here. And it's going to be x final, which is minus 10, minus x initial, which is 5, right? X initial was 5, x final is minus 10, all right? X final minus x initial is minus 10 minus 5, which is going to be minus 15 units, whatever those units are, okay? What does that mean? It means that I started out here at the positive 5 position, but my displacement was negative 15 units. It means 15 units in the negative x direction. So I was going to the left on my graph. Okay. All right, so that's displacement. Okay. And displacement's okay, but it's not everything when we talk about kinematics, but it is very important. Okay. The next thing we want to look at is velocity. What is velocity? Well, velocity is simply when we think about velocity or speed, right, we think of how far we went, right, in a matter of time, right? And so when we think about velocity, velocity is some d displacement divided by time, okay? But we also talk about speed, right? And speed is distance divided by time. Now, are they going to be the same thing? At times they can be, all right, but very often they won't be, all right. And the reason is if we look at our example up here where we had distance and displacement, if I go from point A to point B here, I can take more than one path. If I take the upper path here, that's denoted by all the arrows up on the top, right, I definitely I walk a much greater distance, if you will, all right, going from point A to point B by using this curved path up at the top. The displacement, however, is the shortest distance between point A and point B. It is a straight line distance, if you will, all right, and that is the displacement. It's simply the change in position. So when I talk about velocity, I'm talking about simply velocity is displacement over time. Okay, so let's say I start out here at the positive 10 position. That's my initial x position, and I travel all the way to the negative 5 position. This would be my x final, and I do this in 3 seconds, so a time of 3 seconds. All right, I would like to know what my velocity was during this time. Well, velocity, v, is displacement divided by time. Displacement, though, is just x final minus x initial, again, and now divided by time. So we're going to have x final, which is minus 5, minus x initial, which is 10, divided by the time it took to do that, and that's 3 seconds. Okay, and so, and again, I didn't give the units up here. Let's say that they're meters. So minus 5 meters minus 10 meters gives us minus 15 meters divided by 3 seconds. All right, and this gives us a velocity equal to negative 5 meters per second if I was traveling at a constant velocity. And we're going to assume that our velocity is constant at this point because we haven't talked about acceleration. Okay, so that's how we determine velocity. Now let's say instead of taking that path from going from the positive 10 position to the minus 5 position, I did this. Now I still got there, but I got there over a very different path and a very different distance. Okay, in this case, I want to know what the speed of my travel was. Well, I obviously probably did not do it in 3 seconds. Okay, let's say that the total distance, the path length that I traveled there was, oh, I don't know, let's make it 35 meters. Okay, and I did it in a time period of 8 seconds. All right. What would my speed be? I'm sorry. Well, my speed would simply be 35 meters divided by 8 seconds, about 4.375 meters per second. Okay, but there's no sign here. Why is there no sign? Because speed doesn't really require a sign. Velocity requires a sign because velocity gave us a direction that we actually traveled in. I wouldn't know how to say what direction I traveled in here, right? I traveled all over the place. I traveled north, west, north again, some south. I traveled all over the place. So speed is just a magnitude, whereas velocity is a magnitude and a direction. Okay, so both velocity and displacement are vectors because they give us the magnitude and the direction of what we're talking about. Okay, so that's velocity. Last thing we want to take a look at is acceleration. Okay, so if velocity is the change in displacement over time, acceleration, A, is the change in velocity over time. Okay, when we're sitting at a stoplight in our car and we stomp on the accelerator, what happens? Well, we go from 0 meters per second to some larger number, right? So we go from 0 to say 20 meters per second. And we do that in a particular amount of time. Some car manufacturers like to say, well, we can go from 0 to 60 miles an hour in 3.5 seconds. Well, we can go from 0 to 20 meters per second in 10 seconds if you're riding a bike, say. Okay, and that would tell us what our acceleration is, right? And so let's say that we have an initial velocity equal to 0. We're at a stoplight. And we have some final velocity equal to, say, 20 meters per second. Right? And we're able to go from 0 to 20 meters per second in a time of, we'll make it 5 seconds. Okay? And I'd like to know what my acceleration was during that time. Well, acceleration is just the change in velocity divided by the time it took us to do that. Well, remember, the change in anything is the final value minus the initial value. So this is going to be V final minus V initial divided by the time it took us to do that. All right? And in this case, it's going to be V final, which is 20 meters per second, minus V initial, which is 0 meters per second, divided by 5 seconds. That's the time it took us to do that. And we end up with is 4 meters per second, or 4 meters per second squared. We also write this like this, 4 meters per second squared. Okay, so that's acceleration. So we've covered displacement, velocity, and acceleration. And it's very, very important not to get lazy with displacement, because what you can do is you can end up getting the magnitude part of the displacement correct, but you don't get the sign correct, and that's where you can get into trouble. So we're going to do a few problems, but we're going to do that in the next session. So this is part 1 of kinematics in 1 dimension, and I hope that helps.